Great day everyone. Today my friends and I will be sharing with you a subject related to thermofluids, which is the relationship between pressure and temperature with the application of a Marcet boiler. At the end of this video, you will be able to establish the relationship between pressure and temperature values of saturated steam, and also to compare the obtained saturated temperature and pressure with the steam table data. Marcet boiler is a benchtop unit designed to express the thermodynamic basic principle of boiling phenomenon. It signifies the fundamental pressure-temperature relationship of saturated steam in equilibrium with water. In this experiment, a Marcet boiler is used to calculate the relationship between pressure and temperature of saturated steam. The water inside the boiler is heated by the electrical resistance and starts to evaporate. As more water changes phase from liquid to vapor, more vapor accumulates inside the boiler vessel and increases the pressure imposed on the water surface. This pressure buildup tends to increase the resistance faced by liquid molecules as they change into vapor, consequently increasing the saturation temperature of the remaining liquid.
For a pure substance existing as a mixture of two phases, the Clapeyron relationship relates the pressure, heat, and expansion during a change of phase provided that the two phases are in equilibrium. As you can see, T equal to absolute temperature, Vg as specific volume of steam, Vf as specific volume of water, and HFG as latent heat of vaporization.
First, the boiler was set up for heating and cooling process. This was done by turning on the main switch and turning on the Marcet heater. As the temperature increased, the valve was left open until the temperature remained constant. Once constant temperature was reached, the valve was closed. Readings of temperature and relative pressure at intervals of 1 bar were taken until a relative pressure of 7 bar. Once the readings were recorded, the heater was turned off and cooling process at intervals of 1 bar as well was then recorded. Once the pressure gauge reached 0 bar, the valve was opened once again and the main switch was turned off. The results were then processed and analyzed.
Based on the slopes, it can be concluded that as a gauge pressure of water increases, the temperature reading increases as well. However, there was a slight deviation between theoretical slope and experimental slope. The percentage error ranged from 2.18% to 23.52%. This error is due to certain imperfection while carrying out the experiment. Firstly, there was no measuring equipment present in order to obtain accurate atmospheric pressure. Therefore, the assumed atmospheric pressure under kilopascal is added to the gauge pressure to obtain the absolute pressure. Moreover, the boiler lacked calibration as it was not calibrated before the experiment began. In addition, unstable readings were obtained as the temperature was still changing during visual judgment as energy is continuously flowing. Besides that, there was also human error as visual judgment, which is an inaccurate method, was used to record the temperature reading. Apart from that, the Marcet boiler had a leakage and this imperfection was identified as it took a short period of time to obtain pressure and temperature reading from 0 to 7 bar and vice versa. Lastly, air should be expelled from the boiler prior to measurement recording in order to prevent it from affecting the accuracy of the experiment results. The relationship between pressure and temperature values of saturated steam were established. As the pressure increased, the temperature increased as well. Both pressure and temperature are directly proportional to each other. Beside that, the obtained saturated temperature and pressure were compared with the steam table, and there was a slight deviation. This deviation is due to several sources of error, such as assumed atmospheric temperature, lack of calibration, leakage of boiler, and human error during recording of experimental values. Examples of application of this experiment include water boiler, gasifier, power plants, cooking utensil, and many more. However, some of the limitations are leakage of heat, pressure, and mass.